In Chapter 7, Section 4, we're going to apply all the ways that we learn how to find In Chapter 7, Section 4, we're going to apply all the different ways that we learn how to solve linear systems in order to solve some story problems. So by the end of this lesson, you should be able to write and solve systems of equations from words. So go back to what we did last week. There are three methods to solve a system of linear equations. You can graph it, you can use substitution, or you can use elimination. Graphing tends to be inaccurate, especially when we're talking about a story where decimals could come into play, but it creates a nice visual, so we won't be using that one today. Substitution, used when one variable is alone or really easy to get one alone. And then elimination is good to use when equations are set up in standard form. So let's say that we are testing two fertilizers on bamboo plants. And they're growing under identical conditions, so all that's going to stay the same. Plant A starts off 6 centimeters tall and grows at a rate of 4 centimeters per day. Plant B is 10 centimeters tall and is growing at the rate of 2 centimeters per day. Which system of equations models the height of each plant as a function of days? So we have two plants that we're talking about here. Plant A. So if we were to write this in a y equals mx plus b situation, you have the height, and that is a function of two things, what it started off as and how quickly it's growing. So plant A starts off at 6 centimeters. That's our y-intercept. And it grows at 4 centimeters per day. So 4 times x. Or in this case, x is d for days. So we take a look at all of our options. We can cross this one off. We can cross this one off. So now we're choosing between B and D. So then our second plant, plant B, starts off at 10 centimeters tall. So that's my y-intercept, and it grows 2 centimeters per day. So we can see that D is our system of equations that models this situation. Now if I wanted to solve this, what I would be finding is the number of days until they are the same height. And the height they would be. So this solution means something. Up until this point, none of our solutions have ever meant anything. They've just been numbers that we could check. But in this, they are actually going to represent something. So if we take a look at this, because both of these equal the height, we can set those two things, 4d plus 6, equal to each other, 2d plus 10. And if we go through and subtract 2d from both sides, subtract 6 from both sides, divide both sides by 2, we get in 2 days they should be the same height. So that's useful information, but now I want to know how high they're going to be. So this is where we can take this and plug it into either equation up here. So the height after 2 days is going to be, let's plug it in the first one, 8 plus 6 gives you 14 centimeters tall. So our answer, when we write it as 2, 14, means that after 2 days, both of these plants are going to be 14 centimeters tall. So let's do another one. Your school is planning to bring 193 people to a competition at another school. There are 8 drivers available and 2 types of vehicles, school buses and minivans. The school buses seat 51 people each, and the minivans seat 8 people each. How many buses and minivans will be needed? So this one's a little harder because it doesn't give you equations to choose from, but always stop and think, what don't we know? So the 2 things we don't know are in this last question right here. How many buses and how many minivans? So there's 2 things we don't know. X and Y. Those are the 2 variables we can use. We could use B and M for buses and minivans. It doesn't really matter. But let's let X represent the number of buses we need. and y can be the number of minivans. And now with this information, we should be able to come up with two different equations. So the first equation talks about the total number of people going. So we want to bring 193 people, and this is how many people get seated in each vehicle. So we somehow want to end up totaling 193 people. So each bus seats 51 people. So we're going to make 51 times x, the first part of this. And then each minivan seats 8 people. So these added together should total the number of people that we want to go. And then the other thing that we have going on here is there's 8 drivers available. So there's 8 people that can drive either a bus or a minivan. So we have the number of buses, that takes 1 driver each, plus the number of minivans, again 1 driver, has to total 8 drivers. And now we have a nice pretty systems of equations. You can solve this any way you want, besides graphing. I wouldn't recommend doing that. But it's really easy to get either x or y down here by itself to do substitution, or to make, I would make y -8, multiply everything by -8, and then you could do elimination. Sue has 100 dimes and quarters. The total value is $21.40. How many of each coin does she have? So stop and think about what you don't know. We don't know the number of dimes, so let's make that x. And we don't know the number of quarters, so let's make that y. So then again, we have 2 equations to come up with. So value and total. The total is a little easier to figure out. You know, however many dimes she has plus however many quarters equals that 100 coins that she has in her pocket. And then the money value, remember dimes are worth 10 cents. So we have 10 cents for every x, and quarters are worth 25 cents for every y. And that has to total $21.40. Now, before you start solving this, you could solve it with elimination, substitution, whatever you want to do. Or we could clear the decimals. So one thing that I always like to do is all of these are in dollars. If you multiply it by 100, this turns into cents. So 10x, 25y totals 2,140 cents, which is still $21.40. And then this you can use with that one to solve. So again, I'm going to leave you to solve this one. This will be part of your can you prove it. All right, last one. Suppose you fly from Miami, Florida to San Francisco, California. It takes 6.5 hours to fly the 2,600 miles against a headwind. At the same time, your friend flies from San Francisco to Miami. Her plane travels the same speed, but it only takes her 5.2 hours. Find the average airspeed of the planes. Find the average wind speed. So this problem looks familiar. It's going to be way easier to solve with systems, so don't freak out just yet. Write down the 2 things we don't know. The average speed of the plane. So we'll say x is speed of plane. And then the wind speed, so let's make that y. So then you have u. And remember, you're going from Miami to San Francisco. And it says that you are taking 6.5 hours to fly 2,600 miles against a headwind. So wind is pushing against you. It's slowing you down. So in order to do this, we need to remember the formula that we used way back in chapter 3. Distance equals rate times time. So we flew the distance of 26,000 miles. Our rate, we don't know. And our time is 6.5 hours. Now our rate here is however fast the plane is going, which is x. And remember, the wind speed is pushing against us. It's slowing us down. So this is x minus y here, slowing us down. And then you have your friend. And remember, your friend is going from San Fran to Miami. So they're still traveling the same number of miles. Their speed, however, is a little different though, because they are traveling however fast the plane is going, plus wind speed is helping them. And it only takes them 5.2 hours. Now before we can solve this, we need to get these looking good. We need to get them in standard form. So what we need to do is we need to distribute. That's why I left some room here. So this first one, 2600 equals 6.5x minus 6.5y. And then this one would be 2600 equals 5.2x plus 5.2y. And then it doesn't matter how you solve this. You can use substitution, you can use elimination. I would go through and either clear my decimals, multiply everything by 10, or just deal with the decimals as we go. But just like before, I'm going to have you solve this one all on your own. So when starting a business, people want to know the break-even point, or the point at which their income equals their expenses. So if we take a look at this graph on the right, it shows the break-even point for a business. So this pink line here is how much money they have to spend. The blue line is their number of income. So if they sell like 1 or 2 items, they're spending more than they're making. And then eventually they'll get to a point where they start making more than they're selling. And this point right here of intersection is the break-even point. Everything after this, they are making money. And everything less than this, they're losing money. So here's the problem. Suppose the Model Airplane Club publishes a newsletter. Expenses are 90 cents for printing and mailing each copy, plus $600 total for research and writing. The price of the newsletter is $1.50 per copy. How many copies must they sell to break even? So we need to come up with 2 equations. So the things we don't know are income and expenses, so money, and the number of copies they're going to sell. So money made, we'll make that Y. Number of copies, we'll make that X. So expenses. Expenses are 90 cents for printing and mailing each copy. So our expenses equal 90 cents for each of them, plus 600 bucks total. And then our income is we're charging people $1.50 per copy. So we want to figure out when we break even. So this is a nice easy substitution problem. We can plug this in. So we end up with $1.50x equals 0.90x plus 600. If we subtract 90 cents from each side, we get 60 cents. And if we divide both sides by 0.6, we end up with x having to be 1,000. So this means we need to sell 1,000 newsletters to break even. And at that point, if we plug this back in for both of these, we're going to end up spending exactly the same as what we made. So both of these will total the same amount, which is good, but that's our break-even point. So we need to sell more than 1,000 if we want to make money. Anything less than 1,000, we're going to lose money. And if we sell exactly 1,000, we're breaking even. We're not going to make or lose any money. So that's it. You should be able to write and solve systems of equations from words. I left 3 of them for you to go back and solve on your own. Make sure you write down any questions you have, and we can go over them tomorrow. Have a good night.